Hello everyone. Good morning, Sairam. Children, in the last video we have started chapter number 14, Boolean algebra. So this is the second part of the same chapter. Today we will finish this chapter. Okay children. Now let's see what we are going to discuss today. Okay, before we see what we are going to discuss today, let's see what we have discussed in the previous video, children. In the previous video, we have discussed about gates. Sorry, we have discussed about truth tables, Boolean algebra. What is actually Boolean algebra? What is the meaning of truth values? What are truth functions? All small topic we have discussed in the previous video. Now we are going to discuss about more truth tables. Last time we have discussed and, or, and not based truth tables. Today we are going to discuss about NAND, XOR, NOR. Okay, now after that we are having two topics more, De Morgan's law and logic circuit. So in logic circuit we are going to discuss how to make logic circuit, and after reading the logic circuit, how we can write the expression of that logic circuit, children. Okay, so let's start with NAND. See children, okay, now it's fine. See children, NAND, what is NAND? Basically, NAND is made up of two words. First is and second is not. So when we are combining both and not together, it gives you NAND. Okay, so children, I hope, okay, I have not discussed all the circuit diagram with you. Let's see about all the circuit diagram first, about and, or, and not. After that I will tell you about the NAND circuit diagram. After that only you are able to understand how to make the circuit diagram. So let's see in the notebook. Okay, okay, let's see children about the circuit diagram. See, in the last video we have discussed about or. So how we can make this circuit diagram? Like in this shape. Now concentrate on the shape of the circuit diagram. In this way you can make the circuit diagram. Okay, now in this two inputs go inside this. After that you will get one output. Okay, so let's see if A and B are the inputs. If they are inputs, then this y will be your output. How it can represent? In the form of a plus b, because I told you for or sign we use this plus sign and we use this v sign. Okay, okay children, now let's see how to make and circuit diagram. For and circuit diagram you need to make shape like this. Okay, in circuit diagram children, it can be two inputs also, it can be three inputs also. So I'm giving you example of two inputs. So two input is going inside this circuit diagram. I'm giving name A and B. So this basically this shape is of and. Okay, only one output is coming. Okay, so y is the resultant, and how you can represent A dot B. I told you that and can be represented with the dot sign or with this opposite of V. Okay children, now let's see circuit diagram of not. How we can make circuit diagram not in the triangular shape like this. Okay, in this, if only one input goes inside always. Okay, so if A is input, so as the output A bar will come. Okay, I told you that not can be represented with the bar sign, with this sign also. Okay, so this is your OR circuit diagram, this is your AND circuit diagram, and this is your NOT circuit diagram. So in the slide previously I was explaining you NAND circuit diagram. NAND. So basically NAND is a combination of NOT plus AND. So you need to make first AND circuit diagram. After that, in the output you need to attach one NOT operator like this. Suppose if A and B are the inputs, so here you are getting A dot B. So after applying NOT sign you will get A dot B whole bar. Okay, so this is basically a NAND circuit diagram. Okay, let's move to the slide. Okay, basically this I was explaining you. In the last video I forgot to explain you circuit diagram about AND, OR and NOT. I hope after this you know about all the circuit diagrams. So basically NAND is a combination of and NOT. So here is the circuit of and if you concentrate here, this is a dot sign here, so this represent NOT here. This is a combination of and NOT. So basic diagram for NAND is this. Okay, basic diagram for NAND is this. First AND circuit diagram come, then after that with this dot sign you can put NOT. Okay, now see what is there in the next slide. In the next slide the brief description of the previous circuit diagram. So this is AND. So if A and B are two inputs, after ANDing you are getting A dot B, and this is NOT. When NOT is applying on this A dot B, you are getting A dot B whole NOT, or we can say whole complement, whole bar. Okay, so this is your NAND circuit diagram. Now let's see in the form of truth table, children. See, I again repeating that NAND is a combination of and NOT. So X and Y are the two inputs. If X and Y are the two inputs, see, if X and Y are the two inputs, first you need to find out X dot Y. X dot Y means X and Y. See, if both are 1, you are getting 1. See, what we are doing in AND, we want both values true. So here 1 1 means true true. So your answer will come true. One is true, another is false, so answer come false, because in AND we want both the values true. Again false, true, you are getting false answer. So 0 is representing false and 1 is representing true. Now both the condition are false, so you will get false answer. Okay, now if you, this is your AND column, this is basically your AND column. Now you need to attach with AND NOT. Okay, so NOT means you need to do opposite of AND. So if 1 is there you will get 0, if 0 is there you will get 1, if 0 is there you will get 1, if 0 is there you will get 1. So in this way you can represent two inputs in the NAND truth table. Okay, let's move to the next slide. Now next slide is basically about NOR. NOR means not plus or. In the same manner you are having, in the same manner you are having, see, in this also it is a combination of not and or. So basically you want or circuit diagram plus not. Okay, if we see in brief, so if A and B are the two input, here you will get A plus B. Then when it add with not sign, so A plus B add with this not sign, you will get A plus B whole not. Okay, Now let's move to the truth table for NOR. For NOR you need to make first of all ORing of these two input. So that is why it is written here x plus y. So in ORing, let me make you remember that in ORing, if one value is true and another is false, that is also okay. You will get true answer. And if both the condition are true, that time also you will get true answer. But if both are false, that time you will get false answer. So in this, both are 1, means both values are true. So you will get true answer. In the same manner, here true, here false, so you will get true answer. Here false, here true, you will get true answer. So both are false, so you will get false answer. 0 means false, 1 means true. Now you need to apply not sign on this particular column. Okay, in this particular column you need to apply not. What is the meaning of not? You need to reverse the whole value. Okay, so see, if you apply not in this column, because basically we want nor, so on ORing you need to apply not sign. So if 1 is here, 0 will come. If 1 is there, 0 will come. If 1 is there, 0 will come. If 0 is there, 1 will come. Okay, this is called NOR sign. Okay, now let's move to the next slide. Next slide is about XOR. XOR, what is the meaning of XOR actually? See, we have discussed now NAND and NOR. NAND is a combination of and not. NOR is a combination of or and not. But what is this XOR? XOR means exclusive or. Or in short, we are saying XOR symbolically. Okay. So symbol we will use in this V, and under that this bar sign will come. Okay, requires exactly one true and one false value in order to result true. So in XOR basically you want combination of true and false. Okay, then only you will get true answer. If both values are true, you will get false answer. If both values are false, again you will get false answer, children. In XOR, I'm repeating, you want combination of true and false. It can be false and true also. In that condition also you will get true answer. Okay, now let's see in the tabular form, in the truth table form. See, in this P and Q are the two inputs. So how we are giving input when two inputs are there? 2 times true, 2 times false, 1 time true, 1 time false, 1 time true, 1 time false. Now you have to find out the XOR of these two inputs. This is a sign of XOR. So I told you in the previous slide that when true and false combination is there, then only you will get true answer. See, here true combination is there, you are getting false answer. Here true, here false, you are getting true answer. Here false, here true, you are getting true answer. Here you are having false combination, so you will get false answer. So only true and false combination gives you true answer. Okay, this is called exclusive or we can say XOR. Okay, now let's move to the next slide. Next slide is about De Morgan's law. Okay, see, in this chapter 7 to 9 laws are there, but we will not discuss about that because that is not in your syllabus in this year. Basically it is in your syllabus, but now government has reduced the syllabus, so because of that we are not going to discuss those laws. So in your syllabus in this year only one law is there, that is De Morgan's law. So you have to understand this law and you need to prove this law with the help of truth table. So how we can read this? Basically first law means A dot B. This multiply sign means dot means and. So between A and B anding is there. Okay, so whole not basically this A and B in the ANDing form, and both full result is having not sign as bar. So when we open that, you will get A bar plus B bar like this. Okay, you need to prove this. Second law is A plus B. It means A and B are in the form of OR operator, and it having whole bar. It gives you A bar dot B bar. It means basically, if you concentrate here, this multiply sign converts into plus sign, and whole bar is converting into individual bar. Okay, this is a law. Basically here plus sign is there. Now this plus sign is converting into multiply sign, whole bar convert into individual bar. Okay, so let's see in the briefing of this De Morgan's law. After that your mind will be clear. See, this is the basic law of De Morgan's law. We are having two laws. First law is this: x dot y whole bar equal to x bar plus y bar. So you need to prove this with the help of the truth table. So here two inputs are participating, so x and y are the two inputs. So 2 times 0, 2 times 1, 1 times 0, 1 time 1, 1 time 0, 1 time 1. In this way also you can take input, or like always we are taking 2 times 1, 2 times 0, then 1 time 1, 1 time 0. So they have just reversed the concept here. Now here you need x bar and y bar. So x naught means reverse of x. Here 0 is there, you will get 1. Here 0 is there, you will get 1. Here 1 is there, you will get 0. Here 1 is there, you will get 0. In the same manner with y also, 0 is there, 1 will come. 1 is there, 0 will come. 0 is there, 1 will come. 1 is there, 0 will come. Okay, now after this your x bar and y bar is ready. Okay, so first of all we solve we solve leftmost side. So first you need to do ANDing x into y. So x and y means both value should be true, otherwise you will get the false answer. So both are false, you will get false answer. One is true, one is false, you will get false answer. One is true, one is false, you will get false answer. Both are one, then only you will get one answer. So in the leftmost side, after ANDing you need to do not also. So this is your ANDing. Now on bar means you need to apply not operator. So not means you reverse. So instead of 0 you can write 1, 0 convert into 1, 0 convert into 1, 1 convert into 0. So this is your leftmost side, this is ready. Okay, now after that you have to make this rightmost side. Your x naught and y naught is also ready, you have to do ORing between both of them. So concentrate on this column only. So ORing means only two zeros gives you false answer. So both are 1, you will get one answer. One is one column having 1, one column having 0, so you will get one answer. In this also you will also get one answer. Both are 0, you will get false answer. So now compare, this is your leftmost side and this is your rightmost side. So both are having same answer. It means you have proved De Morgan's first law by using the truth table. Okay, now let's move to the next is the second law of De Morgan's law. Second law is when both are x and y are two inputs, they are in ORing. So complement on that gives you individual complement with ANDing. So again you need to make column for that x and y, then x and y do ORing, then you can find out x naught y naught separately. Then on this you can apply not sign. After ANDing, after finding not, you can do ANDing on that. So after that you will get the same answer. Same procedure you need to follow like we have done in the previous one. Okay, now let's move to the logic circuit. See, individually now you know what is the logic circuit for and, what is the logic circuit for or, what is the logic circuit of not. So now what kind of question can come in your exam, children? Basically, one full expression can be given to you and you need to make logic circuit for that. Let's see how. See, this is a question I'm giving you. Draw the logic circuit for a following boolean expression. So this expression is given to you. You need to make the logic circuit diagram. How you can make? Let's see. I will show you in the notebook. So this is your question. See, here x naught plus y means x naught and y is having ORing sign. So first of all, make two inputs. First is x and second is y. So on x naught sign is there, make naught sign like this. You will get this, then y. So between them OR is there, make OR sign like this. Okay, you get this full. It means this is x naught plus y. Okay, this part is over. Now this is the meaning of ANDing. So this is the output. You move forward like this. Now let's prepare this. It means you have to give one input, that is z plus w naught. So another input is w. Put naught sign, it gives you w naught like this. Now between z plus w naught there is a OR sign. Make this OR sign like this. You will get again one output that give you z plus w naught. Now this and this is ready. Between them AND sign is there. So make one big AND like this. So you will get this answer, x naught plus y z plus w naught. I hope that circuit diagram is clear to you. Let me give you one more time explanation on the slide. So this is the same question which I have made. See children, let me explain you. Here x bar is there means x naught. So x is the input, naught sign is there. After that you will get x naught. Now one more input is there, y is here. So between x naught and y OR sign is there, make OR. So you will get this x naught plus y. Okay, now z and w naught you need to prepare. So z is there with w naught sign is there, you will get w naught. So z plus w is there. So between x naught y and z plus w naught ANDing is there. So this is your AND circuit diagram. Okay, in this way you can prepare a circuit like this. Okay, now next question is write the boolean expression for the result of the logic circuit as shown. In the previous question one expression is given to you and you need to make the logic circuit, children. But in this question circuit diagram is given to you and you need to find out the expression. See how. See, from here u is coming, here v naught is there, so OR sign is there, so u plus v naught. Okay, now from here u is coming, from here w is coming, means u plus w. Okay, from here v is there, from here w is there, v plus w naught. Okay, now between u plus v and u plus v naught ANDing is there. So u plus v naught, u plus v. Okay, one input. From here another input is coming, you will get this final result. So let's see the answer how we can do. See, from here one is there, then from here you will get u plus w, from here you are getting v plus w like this. So between these two this answer is coming, between these two this answer is coming. So basically you concentrate on the circuit diagram and dividing the small part, you will get the resultant. Okay, now with this I'm ending the video, children. In the next video I will provide you one PDF, the whole notes of this chapter, Boolean algebra. some practice question is also there in that. Try to solve those questions. Okay, I hope you can do all the questions belongs to this chapter. Till then, take care of yourself. Thank you so much. Sai Ram.